Hello friends, welcome to another video in my YouTube channel on LangChain series, and in this video we are going to cover external memories supported by the LangChain. So in all the past videos we have seen different types of in-memory conversations in which the memory history was getting stored in the RAM inside the memory. So the clear disadvantage for that is that whenever your system refreshes or your application restarts, that gets cleaned up. So whenever your app will refresh, this will get cleaned up and you have to build your memory from scratch again. So in real world applications, you need a way where you can persist your memory even if your application is not online or if it is not running. So we have two different types of memories in LangChain, which is file based as well as the database based. So first we are looking into file based storage. So there are two implementations that I will be showing you in this video, which is the first implementation is using BaseChatMessageHistory class, which we have seen in our first video on memory in LangChain, which allows you to implement your own memory by your own standards. And the second is the custom class that is provided by the LangChain itself, where it by default automatically stores everything in a file. So if you remember BaseChatMessageHistory class, this is a base chat class which you can inherit in another class, and then you have to override some properties and methods to make it work with. So as you remember from my first video, we have to inherit a property called message and return us the messages that we are storing, then a method called add messages, clear, add user message, and add AI message. So if you will look into the implementation of these methods, it's like more or less similar that we have seen in the simple in-memory chatbot. Then in the add messages, I'm just adding the messages to my list, and also I'm saving to a file to make it a persistent external storage. In the clear method, I'm just clearing the internal messages as well as the file. And in add user message and add AI message, I'm storing the human message as well as the AI message using this add messages function. Now if you will see the implementation of init and load from file. So in the init, I am initializing my messages, the file path, and I am just loading the file if it is present. So if it doesn't present, then we just return as the initial list will be empty. Otherwise, we are opening the file in the read mode and loading the whole JSON, and we are just converting the messages into a human message or AI message based on the type that is stored in that particular message. For example, if the type of the message is human, that the prompt that is sending the prompt that human is sending to the LLM has a type as human, and the response that is coming out from the LLM has type as AI, and depending on that, we are converting the string to a human message or AI message for the LangChain perspective. Now if you will see save to file function, here we have a simple format, and we are storing messages in a simple format which has a save date field, the date time field, then the total message count, where we have the count of all the messages in our conversation history, then we have a list of messages. So if the message type is human, in this human message we are just storing the type in as type, and we are storing the content of the message and content field. So if the message type is human message that is coming from here, then we store it as a human, the type human, else we store the type as AI, which we are using here as well while loading the file. So this is the manual implementation of file chat history, and if you will go below, this is how we are using it. So if you remember from my first video, we have created a simple chatbot, right? So if I just show you the implementation of simple chatbot that we have in our first video, let me go to the top. Yeah, here it is, right? So here the simple chatbot takes a memory type, a base chat message history memory type, no matter if it is internal memory or if internally it's storing to a file or database, and it takes a LLM instance and it takes a system prompt. Now it has two functions, which is chat as well as the show history function. In the chat, it takes the user prompt, combines it with the system prompt, and it calls LLM, and then after the LLM gets a response, then it stores that response as well into the memory that is defined, that is being passed here. So no matter what your memory implementation is, whether it is internal or it's storing to a file or a DB, this method will just call the overridden methods present in this memory class, and it will store all the conversation in this memory. Then we have a show history method, which will just return all the different types of history or the history that is present in the memory. So this is the basic implementation that we have already seen in the first video. You can just check that out. Now I will just go back to the file history. Let me go down. So here we are using the same chatbot to implement our memory. So we have created a file chat history, which is our memory class. Then we are passing this class to the simple chatbot along with the LLM instance and a system prompt. Then we have some list of questions that are coming from the user, like I want to learn web development. Then the second question is, should I learn React or Vue first? And then how long does your recommendation take to learn? So if you will see it, these are the list of questions that we are asking LLM using the bot that we have defined here. So let's run it. And the last, we are just showing the whole history that is being returned or that is being present in the memory, in our file-based memory. So let's run this code. I'll just run it. So as you can see, we have started our conversation. This is our first question that is going to the LLM, and we have an answer here. So this is our response from the LLM. It just gives different types of languages. Then if I scroll it down, let's see it from here. So this is our turn one, the first question. Then we have our second question, should I learn React or Vue first? Let's talking about React and Vue in that. Then we have how long does your recommendation take to learn? This is the response for that. So this is our then this at the end we have our history. So if you will see in the conversation directory, a file has gotten created, file tutorial.json, which we have mentioned here as well in our code. So if you will see, we have mentioned the same file here to store the conversation in this file. Now if I open this file for you, you can see it contains every conversation that is happening with the LLM along with the responses of the LLM. So if you will see, we make 3 prompts, right? We make 3 calls to LLM, right, with 3 questions. So we have total 6 messages here, 3 from human and 3 from AI. So now if you will see, as this file is some persistent storage, if you close this application, if I close this session and if I just run this code again, what it will do, it will load this class, and when this class will get initialized, it will load the data from this file that is already present and will store that in this message list as well. So your conversation history is not getting lost once your application quits. So this is a file-based memory. You can try it on your own. I would recommend to write this code on your own by looking into this video and try it on your own. That will give you a very good understanding of how this works. Now let's see the FileChatMessageHistory class that is provided by the LangChain. So as we have seen the manual implementation where we are creating a file on our own and storing the data in that, this is a class that is provided by the LangChain and it does the same for you. So here I'm just providing a chat prompt template where I have a system prompt and I have message placeholder to store all the history in my prompt and the human question. Then I'm just initializing a FileChatMessageHistory class from this function, and I'm just mentioning the file name here, conversation/sessionid.json. So in this, I'm just storing conversation in different files for different sessions. So runnable with message history, I'm using the same class that we have seen before. So it takes a chain, which is a simple prompt and a LLM chain, and the way to get the conversation history, input key, and as well as the history message key that is present in your prompt. Then you can just invoke it like a normal chain. So the question is, my monthly salary is this, I invest this every month, and with a session ID. Then we have another list of questions, how much do I invest every month, with the same session ID, and we are just finally getting the history for this user and printing it. So let me run it quickly. So as you can see, the implementation for this file chat message history is like very similar to in-memory chat message history, because all those classes behave in a similar manner. So you have to just initialize them and use them with runnable with message history, or you can have your own implementation, and also you can use that as well with the runnable with message history, as we have seen in our first video. So if you will see, after running this, the whole conversation is happening with the LLM in the response, and you can see another file has been generated, finance user, in the conversation directory. So if I open this file, you can see it has its own structure. So as you can see, this is a lot of data. So we have a type as human here, then we have data, then we have metadata as well, the whole response that is coming from LLM. I think prompt token details, cost, and everything. Then this is AI response, and then again a human, then AI response. So along with our message, with this content, it's adding all the metadata as well in this file. So this is how the class that is provided by the LangChain works for us. So it works for simple use cases. So that's why I showed you two different implementation. So because this file chat message history has its own structure like this. So if you want a different structure like we have done here in the file tutorial.json, a simple type and content, instead of storing all the metadata, you have to implement your own. It doesn't really allow you to change the structure or things like that. So it depends on the use case. If you want to work with file chat message history, you can just use it as it is. But if you want to have your own business logic or cleanup logic or anything that you want to do on your own, you can just implement your own external memory based on a file like this we have seen in the previous example. So let's move to our next memory type, which is database memory type. So again, I will be showing you two implementations. One is the manual one using BaseChatMessageHistory, and one is the class provided by the LangChain. Here I am doing similar things. So I will be going through it very fast. So I'm just initializing my DB here. I'm initializing my session ID, message list, and I'm initializing the database and loading the database. So in the init database, I'm just checking if the database is present. If it is present, I'm connecting to it, and I'm just executing few commands. I'm executing few commands to create the table structure that I want. So this is manual implementation. Here you can store the messages in any format as you want. Like you can create multiple tables, or you can store everything in a single table, or however you want. You can just decide your own structure. Then I'm just running this command to create all the tables that I need. Then I'm closing the connection. Then from the load from database, which is my init as well, in the init I'm just loading everything from the database if there is any past conversation present. So here I'm again initiating the connection. I'm selecting everything from the tables I want, and again with the depending on the role, if the role is user or AI, I'm just converting it to human message and AI message, same as we have done in the file just from the database. Save to database has similar functionality. I'm just opening the connection and start inserting any new content, any new message, either by AI or by user into the database. And we have similar methods overridden here, which is a message property, an add message function for which stores for any message. It just calls this save to database function to store the message in the database, and it's just calculating the type as well. So depending on if the user instance is human message, the type is human, otherwise AI. Now in the clear function, we are just cleaning up our database, and we have a add user message and add AI message as the same implementation that we have in the all other classes. For user messages, we are using human message class. For AI messages, we are using AI message class. Now we have similar implementation for the users here as well. We are initiating our database chat history that we have defined here, the class that we have defined here, and we are again using a simple chatbot, now this time with a database chat history instead of a file-based chat. Now I'm passing my database chat as well as the LLM and system prompt to it, and we have a list of conversations present here. So I'm talking about my new data science, where do I start, Python or R first, or what projects after basics. So we have seen this code before as well. So this is the same code, but this time it's just using a database as an external memory. Now let me run this code quickly. Let me first initialize this class. Let me run this cell, and then this. So as you can see, as soon as I ran this and the conversation starts with the LLM, there is a tutorial.db that is getting created in my conversations directory. If you will see here. Now if you will see, let's see how it looks like. So let me run this block as well. So as you can see, as all the conversations that I have done before has the same session, right? So I'm using a single session 001 for all the conversations, right? So if you will see the data that is present in my tables, I created two tables, right? Messages and sessions. So this is the data that is present in my tables. In the first table, messages, I have a ID and a session ID, then the role as user and AI, then the content and the date created it. So this is the content present in my first table. And then in the second table, I have a session ID and the created date. So with this, you can have multi-user support as well, right? For example, let's say multiple sessions are going on. So there is some Alice session going on, there is some Bob session going on with different chat histories, and Bob and Alice have their own set of questions. So Bob has talking about machine learning. Alice is talking about machine learning, and Bob is talking about React. So if I just run this block again, yeah. So if you will now load the database classes again, let me just run this block again. So as you can see, along with the session 001, that was the initial conversation we had in this cell, we have now different sessions for Bob and Alice as well. So if you will, I will just make it scrollable and let's see here. So there we have Alice session here as well as in the table. So this chat is coming from LLM, so it's not coming like very formatted manner in this demo, but this is the response given by the LLM. Then we have Alice session. Alice tell me about machine learning. This is the response from LLM. This whole thing is the response from LLM. Then we have a Bob session. How do I set up React? And this is the whole response coming from LLM. Now if we are go to our session class, session table, we have three sessions, which is Alice session, Bob session, and session 001. So for each session, you have isolation. Like each session will have their own conversation history in the database, and you can just load the history for a particular session as well. So it allows you to support multiple users. Now let's look into the class, which is SQLChatMessageHistory provided by the LangChain. So as we have seen with all the other classes, it's very simple to use. You have a prompt template where you have a system prompt and the user prompt along with the message placeholder. Then you initialize SQLChatMessageHistory and the getHistory function as we have seen above with a DB name. Then you can use it with runnable with message history, where you pass a chain, a getHistory method, input, and history key. Now if I call this method like a chain using my user prompts, I have provided an order number and product, and then my order number is this and exchange shoes. Then what is my order number and what order number I mentioned. So I'm initiating three conversation with the LLM, and I think in all of them this session is different. So the first session is about customer one, where my order number is this 1001. Customer 2 is talking about order number 5001, and again customer 1 is asking about the order number which he has mentioned. So let's run this block. So let me run it and let's wait for it to get completed. So as you can see, as soon as I ran this, there is a customer support DB getting created in my conversations directory. Now if you will see the LLM response, let's look into it. So this is customer 1 history. So this is the first prompt that is raised by customer 1, then AI, and then human, then AI. So let's see what is getting stored in the DB. So this is the conversation that is happening with the LLM. So customer 1 is talking about order 1001, then customer 2 is talking about order 5001. These are the LLM responses that were given by the LLM for each of them. Then this is the final question that is raised by the customer 1, where he is querying about the order number he mentioned, and LLM is responding with the correct order number, order 101. Right? So this is how it works. The only thing is, in this particular class, it maintains an old table structure. For example, it will create a table called message store, in which it will have ID, session ID, and message. So if you want to have a different table structure, you want to store different things in different tables, or you want to have your own business logic for clearing or storing messages, you want to store information in your own format, then you can just implement your own database types memory implementation using BaseChatMessageHistory class. Otherwise, for simple applications, this works really fine. But if you have your own format, if your company or if your project has its own decided format or more complicated logic, you can implement your own. So this is about message class. So next we have a hybrid approach as well. Hybrid approach is nothing, just the combination of approaches. Like if you don't want to go with like only storing data in file or in DB, you can do different, you can have different layers as well. Like you can store in memory as well. Then you can have a backup in database or in the JSON file. So for example, initially I'm here. I have created a hybrid chat history class with the same implementations as well. I have a add message implementation, clear, add user message, and add AI message functions listed here. Now in add messages, I'm storing messages in the DB as well as I'm taking a backup to the JSON. So this is a hybrid approach where you can use multiple options. Because this is your own implementation, this class allows you to write your own implementation. You can do whatever you want according to your own requirements. You can have a caching in between, you can have a database as well as the file for backup, whatever you want. So if I just run this class, so you can take a look at the code here. In the backup to JSON, I'm just storing everything in the JSON file. And if I just talk about the users, in my hybrid chat history, I'm providing my DB as well as the hybrid backup JSON file. So now it takes two memory inputs. One is DB, one is file. Now this I'm just passing to my simple chatbot. So as you can see, I'm using simple chatbot for every use case. I'm just changing my memory type. So this time I'm just passing hybrid memory to it. Previously I passed file-based memory as well as database memory, because all of them are implementations of BaseChatMessageHistory class and they follow the same structure, same methods provided to them. So my simple chatbot will just call these methods no matter what they are doing internally. Either they are storing data in their database or file, or they have a hybrid approach. So the same thing we are doing again. I'm just asking few questions to the LLM about DevOps, where to start, then Docker or Kubernetes, or what cloud platform should I learn. So let's run this block. I hope I run this cell as well. Let me run it again, and let's run this cell again. So we have our answer from the LLM. Where user I want to learn DevOps. This is the response. If we scroll, this is at turn 2, Docker or Kubernetes, this is the response, and for turn 3, this is the response given by the LLM. So this is what that is getting stored in the memory, and you can see, if you will see here, we have a hybrid DB present here and hybrid backup JSON file present here. So if you open the hybrid backup JSON, we have the same format that we have defined while storing, and we have the history in the file as well as in the DB as well. So now it depends on your use case and your requirements, how you want to use which class and how you want to implement things on your own. Now this is a list of the classes that LangChain provides for different types of memory. So we have seen BaseChatMessageHistory memory, like it's a custom implementation. You can decide your own logic. So it provides maximum flexibility because you can do anything you want. You can integrate with any type of storage, either Postgres, MongoDB, or that's your logic, right? You can integrate it with anything. Obviously, it requires custom implementation, more development effort, maintenance, and not beginner friendly because you need knowledge for a particular database or thing to do that. In memory chat message history, this is obviously not a persistent or scalable thing because it stores data in RAM, both in memory chat message history and chat message history. As we have seen before, that once you quit your application, the whole thing goes away and you have to start from the scratch. But for learning perspective, for demo perspective, it's the best, simple to use, fastest performance because it's stored in RAM, and good for beginner level, like for learning purpose. So the cons are same, like memory usage grows with conversations as well as the limited production use. It cannot be used in the production. Then file chat message history, right? So here you are storing things in a file. Obviously this is persistent, like if your application quits or refresh, the data will still be there, but it's not scalable. Again, not suited for many users, many real world projects, but you can use it for small demos or small projects where you have your sessions very small. Then we have classes for different types of database, for example Redis, for Postgres, for MongoDB, and SQLChatMessageHistory we have already seen, right? Similarly, we have a class for streamed chat message history. So we have already seen a demo on SQLChatMessageHistory. It supports different types of SQL databases like SQLite, which we have seen in the demo. It also supports MySQL, PostgreSQL, and etc. So you can make it work with different types of database. You don't have to work only with SQLite or things like that. But if you want to work with a non-SQL database, then we have MongoDB chat message history, and we have a special class PostgreSChatMessageHistory that is dedicated for the Postgres database. We have Redis chat message history as well to work with the Redis, and Streamlit chat message history as well. So as the name suggests, they are all dedicated classes for their own databases, and they support all the advantages that comes with these databases. So you can just try these on your own. Like if you have a Postgres SQL, like just set up a Docker container and create a role Postgres SQL, and you can just try this on your own. This will be very similar to that we have seen with SQL chat message history. It will be very similar. Like you just have to create a connection, pass the connection inside it, and you can just use it with the runnable with message history. It will store everything in your Postgres SQL. I'm not doing that. I will leave that as a homework to you. But all these classes are provided by the LangChain to make the life easier. Otherwise, you can always use BaseChatMessageHistory class to implement your own memory. So this is all for today's video. I hope you liked it. Please like, share and subscribe, and in the future videos we will be seeing more advanced concepts of memory, like token uses, limiting token uses, or error handling, and multiple parallel conversations that is going on with your database. So multiple concurrent sessions as well. So please stay tuned for all the advanced concepts, and please like, share and subscribe, and have a nice day.